Hello. Hey, everyone. I'm Nico. I'm from Buenos Aires. I'm NZGB on Twitter. I'm Bebaco on GitHub. I'm a JavaScript consultant, and I'm here to talk about high performance in the critical path. So this is something that interests me because I started a blog a few years back, and it was really, really slow because obviously I'm a nerd and I like doing things on my free time, so I just wrote the entire thing myself. It turned out not to be such a great idea, and then I ended up with a client-side rendered thing that took a really long time to load. So over time, I became obsessed with performance. So there's basically 3 steps that we need to take to fix this kind of issues. And they're very well delimited. First off, we need to measure what we currently have and figure out whether we are doing things right or where we are slacking off, whether we are caching stuff or not. And there's plenty of tools to go over this kind of scenarios, so you don't have to manually check HTTP headers for every request and whatnot. So the first thing that we need to know is what is going on our sites. And there's plenty of tools to do this. One of them, the quickest way you can measure something like this is just going to your site, opening up DevTools, going to the Audits tab, and firing up an audit. And it'll produce something like this, where you get different rules and where, if you're passing them or not, like are you combining all external JavaScript, are you caching stuff, are you, have you enabled keep alive, is gzip enabled for all text content and whatnot. So this is a very fast way to get started into what's going on with my site, right? So you get advice for every resource, and you also get some advice regarding caching best practices, also for every resource, and there are some more general purpose advice too that you should follow. Another tool is PageSpeed Insights. If you don't know this one, you should check it out. That's the URL, or you can just Google it. Here, basically, it's a hosted service that Google has for you. You just enter your URL on their site, and it'll take a couple seconds to run an analysis on your site. And you'll get different views, like how's it working in mobile and how it works on desktop, and you'll get a score from 0 to 100 that's going to tell you roughly how good or bad your situation is. And again, it'll give you a set of different rules and whether you pass them or not. But it's also a lot more comprehensive than the DevTools version because it actually has a lot of resources that can help you fix the issues that it finds. And the other cool thing is that it also cares about UX. So for instance, the mobile version might tell you that tab targets are too small for human fingers and stuff like that. So this is another great tool to use. You roughly get a score that tells you how you did. And again, you get best practices and practical advice too. Another version of a service that does this kind of thing is WebPage Test. WebPage Test is a little bit different from PageSpeed in that it's a lot more comprehensive in what it measures. It measures requests down to the TCP level, so you get very fine detail on what's going on. And there's quite a few different actionable things that you can tell using WebPage Test that you really couldn't otherwise, or at least it would be harder with other tools. So just like in PageSpeed, you enter your website's URL and you start testing. One of the big differences is that it will place your request on a queue, so it won't immediately start crawling your site, but instead it'll make you wait maybe 5 minutes or something like that. But if you choose a location that's not filled up in its queue, it's going to be much faster. And here you get grades in different areas, like the time to the first byte in the connection, whether you're caching or not, whether you're using a CDN. In this example, we have an X there because we are not doing anything like that, where you're compressing images and stuff like that. And then you get this view where you are told how long it takes for the page to load on the first load and on the second load where the cache is supposedly primed. So there should be a big difference there. And you also get this waterfall view where, let's skip that, where you have all the resources and how they are blocking on each other. And here you can tell, for instance, that the CSS is blocking all of the fonts because they're in the CSS, right? But that's in turn blocking the JavaScript. So if we found a way of deferring the fonts and the JavaScript, the page would load like 2 seconds faster or something like that. So this is really something that we should be placing more interest on. And it also gives you, like, again, like I said earlier, very fine, detailed grades on all of the requests and not just on a whole scale. And you also get this, what they call a film strip view that basically makes it very, very easy to tell if you have issues like most of the page actually loaded, but we are not displaying anything because we have what's called a flash of invisible text. And in this case, again, what we should be doing to fix it, as we'll see later, is deferring the font loading and just using some website font first. And that way we would get rid of all the blanks in the page where even though the content is there, we're not displaying it because the font isn't there yet. And for the most cases, unless you're obsessed with typography and stuff like that, it's fine to just display it in a slightly different font and then load the other one on top. So it makes it very easy to spot flashes of invisible text and fix them. And it calculates something that's called the speed index. That's basically a number that tells you how much of the page has loaded over time. And it's defined very complicatedly, but it's that. It takes the visual progress of the visible page loading and computes an overall score for how quickly the content is being painted. So with WebPage Test, you get an inspection for every request. You get to analyze TCP traffic. You identify bottlenecks, and you can visualize progress. So with all of this, you can really, really gain a lot of insight into what's going on in your site and start fixing things. But the problem is that if we end the talk right here today, you would go back home, or maybe even just here on your cell phone, visit your page, figure out what's going on once, never go back to that again. Maybe you fix a couple issues and whatnot, but the problem will just come back in a couple of weeks or a couple of months or a couple of years. So it's something that we should be doing actively and constantly. So this is something that we could obviously automate, but from what we've seen so far, it's kind of difficult because you have the DevTools thing, not something you can really automate, and the website services that are kind of clunky to automate with Selenium or something, right? So there's actually CLIs that allow you to do this kind of thing in your terminal. So one of them is PSI. PSI is short for PageSpeed Insights. It's basically a CLI written in Node that allows you to just pass in a URL and run that against your site. You'll get a pretty printed response. That's basically all the content that we just saw on the PageSpeed Insights page. And there's also a programmatic implementation of that, so you can just integrate it with Gulp or anything, really. Again, WebPage Test also has a CLI. This one is a little bit more annoying because, like we said earlier, requests get put in a queue first, and then you have to wait. So the first time you call this, they give you a URL. You have to ping for a few seconds before you get the response. You obviously can write a script that does the waiting for you, but they don't make any assumptions like that, so you have to do it on your own. But you still get, like, the level of granularity this gives you is ridiculous. Just try to run it once, see all the raw data, and you'll be impressed as to all the things that you can do. Once you have all of this, you could do something like diffing of your previous results with your current results, maybe on every build, on every deployment to staging, and you'll get a much better insight into how your changes are affecting the performance in your sites. Another tool is Wiselo. We didn't really go over the one in the browser extension because it's pretty much the same as the PageSpeed Insights and the Tools Audits, but it's a little bit older, so it's kind of outdated. But it's still useful. It also gives you a grade and a score and whatnot. And you can run it over Grunt or with Phantom.js, which is a headless browser directly. So you can also run this on the command line. And all this measuring, right? I mentioned you could run these things on your build processes and maybe on every deployment to staging. But you could also take this a step further and say, OK, so I really actually care about performance, so I want this build to fail if something is going too slow, right? So there's a couple of ways you can determine what's called a performance budget. That's basically saying, OK, the page must take 2 seconds or less to load, or we must make less than 100 requests to serve a web page, or we must ping at most 20 analytics trackers, or stuff like that. So what should you track, right? Well, turns out there's a lot of different metrics that you can use. One of them is Milestone Timings. That's basically saying the time that it takes for the site to show the first relevant content, like an article or a tweet or something. Time to first tweet is actually something that Twitter blogged about, and it's pretty interesting. Speed index is another one. Speed index is pretty nice because it gives you an overall score that's pretty tied into what performance in your site actually looks like. And that's not something that you get if you are tracking something like quantity-based metrics, which, yes, are very easy to do, right? Like you measure how many requests were made or how big the site is. But they don't really give you insight into how much of that content was loaded over time, because maybe if it was loaded right before the page ended loading, but all of the content was actually readable already, then it doesn't really matter that much other than the browser loading indicator spinning. And then you get even easier things like rule-based metrics. like the Wieslow score or the WebPage Test grades and whatnot. So yeah, you could obviously also mix and match these things to get a better insight into what you're trying to accomplish. But the end goal here is to, first you have to figure out which kinds of improvements you can make and which ones you shouldn't care so much about, and then measure that and enforce those measurements. Make sure that if the build is, if this check fails, then the build fails also. That's a really important and easy way to make sure that performance stays relevant for everyone involved in the team. So yeah, another tool, this time grant-perf budget, that allows you to set a ton of configuration options that that allow you to set all these budgets that we've been talking about and enforce them. So if one of the requirements, so to speak, isn't met, then the whole grant build will fail, and that just allows you to not make the deployment to production or whatever. So what can we do to actually improve performance? Because so far we've been talking about how we can identify issues, but how do we actually fix them? So to do that, we have to look at the complete web stack, and that means TCP, HTTPS, HTML, CSS fonts, images, and JavaScript. So let's do that. First off, we have networking. And in this regard, I highly recommend that you read this book from Ilya Grigorik, High Performance Browser Networking. It's really interesting because he speaks about all of the lower level protocols that underline the web, such as TCP, HTTP, but also the newer ones like WebSocket, WebRTC, and stuff like that. He also makes a lot of emphasis in mobile networks and UX around that, and how a big site might be a really huge problem, and a bigger problem that we make it out to be for mobile users, because they might be walking down the street and jumping from antenna to antenna and having a very spotty connectivity. So this is also something to keep in mind when designing for performance. That it also improves UX, right? So optimizing TCP is actually kind of obscure, but there's two things that you could actually do that are not so hard. The first one is increasing the initial TCP window size, and that basically means that the connection will start with higher throughput. And the way you do that is basically update to the latest OS version. And they usually have sensible defaults nowadays to accommodate for that. The second one is disabling slow start restart, which basically means TCP works in a way that it tries to balance out when the connection has been idle for some time. It goes down on the throughput to the safe levels. And the problem with that is that HTTP by nature is very bursty, right? You make a request, you wait, you make another one. And if you are using Keep Alive, which you should, this kind of defeats the whole purpose. So you can disable this using that command in the slides, which are on my Twitter account, on any Linux box. Then HTTP, just make less requests, right? And we can all go home. Turn on Keep Alive. It's usually really easy to do. Many web servers enable that by default. Gzip, everything, obviously. That's text. Add expires and tag headers. This is something that we usually tend to leave for last and end up never doing, but it's really useful. Use a CDN if you should. which means research and look into using a CDN, but don't just blindly throw your site behind a CDN, because sometimes it can be overkill if you're just running a blog, right, or something like that. So look into it, but don't go overboard. HTTP2, speedy, yes. If you can use them, use them. Nginx supports speedy, and I'm pretty sure there's some sort of extension that does HTTP2 as well. So if you, in case you don't know what these are, it's basically the thing that's going to revolutionize the web as a whole, because it's, in most cases, it gives you like a 50% improvement on the connection as a whole. And it does that by using a single TCP connection. You remember when we had to do like sharding, because 3 or 4 connections would block the entire browser's connection to our site, so we would use shards in order to hack around that and allow the browser to open more sockets against our site and all of its subdomains. So what this does instead is it uses a single TCP connection, but it's non-blocking multiplexing, so all of the requests go through the same connection, and it's reused, so it's one connection per domain. Per origin, right? You get header compression, which is basically like really, really important, because for many requests, the biggest or an important part of the request is the headers. And you must be thinking, well, but I have like content type and accept and cookies and whatnot. And yeah, the cookies are, for the most part, usually the problem, because you tend to get a lot of analytics cookies and whatnot. So header compression, how it works is basically, since we have a single TCP connection, it maintains a cache of all the different headers and values, and if it's something that either side has seen before, then it's just mapped like gzip, I guess. So the content is not sent over every single time, as long as it hasn't changed. And you get proactive server push, which is basically to say that when the server is serving the HTML content, it can in parallel also hint to the browser that it should be downloading this JavaScript, this CSS. So the browser doesn't have to wait for the whole HTML to load in order to start making the waterfall for all of the other resources. So yeah, the web needs us, right? So optimizing HTML, well, rendering the server side, that's the best single piece of advice I have for you in this slide. So yeah, if you're using React or something like that, then you can already do server-side rendering. If you're not, you should look into doing something that allows you to do server-side rendering. A lot of the client-side frameworks are now trying to find out ways in which they can support server-side rendering, because they've realized it's a huge performance problem not doing so, because, well, the site has to serve the HTML, has to serve all the images, the CSS, the JavaScript, and only then it can start interpreting the JavaScript, figuring out what view is going to be rendered, render that, run the client-side controller, and by that time, the user is long gone, right? So you can become a single-page app later. And the way that works is basically you serve HTML with everything that the user needs to see, write the content. That's the only thing that matters, really, as a user. And then you can add in the client-side rendering engine and allow that to take over the server-side rendering thing by hijacking links and whatnot. You can throw all of your analytics requests and whatnot. And you should also defer any non-critical asset loading. Again, this means the content is all that matters. So if you have 20 images in your page, chances are maybe 5 of them are in the top of the site what's called above default. But the rest are just nowhere to be seen, and they're still loaded and blocking everything else. So you can easily use some attribute hacking and changing it around as the page loads and make it faster to load. And yeah, you should keep it accessible too, because again, this is where I see UX and performance being pretty tightly knit together. When it comes to CSS, the best thing we could do is inlining critical CSS, and this means everything that's seen in that first above default. Imagine this is a web page, and everything that's below the curtain is below default. So the critical CSS would be every single rule that's needed to have the site be rendered exactly like this. And it doesn't matter if the user scrolls down and sees the comment box like gibberish, because eventually they'll get it asynchronously. But the point is that if you inline the critical CSS in a style tag, you aren't blocking rendering on the CSS, and that's huge. You can also remove unused styles. Obviously, don't do this by hand. No one will ever. But you can use a tool called UnCSS that we'll see later to do that. Avoid them domains. Just make responsive websites or apps. And you'll be far better off because you won't be trying to cram everything, every single device into either mobile or desktop. That usually doesn't work out. Obviously, concatenate and minify and follow a style guide. Seriously, following a style guide is the best single thing you can do with CSS, besides preprocessing and whatnot. But if you don't, your team is just going to, there's this concept that I heard that's called append only. And that means that CSS is something we always add to when we want something because we don't really know what's in there. It's like a black box. So if we're following a style guide, some of those problems can be mitigated, and we get a little more reuse out of it. When it comes to fonts, load them asynchronously if you can. Use a fallback while they load. Prevent flashes of invisible text as the page loads using JavaScript. Use fewer fonts and avoid repaints. Yeah, that sounds great, right? But if you're working with any designer at all and you go back to your team and be like, yeah, we need to ditch these free fonts, they're not working out, he's just not going to do it, right? But in your next project and whatnot, you should try and work with the designer on those issues and try to figure out what's a good constraint to set for the project. And maybe you are like, OK, we can use 2 fonts. That's OK. And again, constraints are great for design, actually. So this is something that you should consider in the future. And obviously, cache the hell out of fonts because they are huge and expensive to load. So that's an obvious one. When it comes to images, we should be minifying and shrinking them. And this means not just running a lossless compression over them, but also if you have user-uploaded images and things like that, they tend to be freaking huge. Like if you take a screenshot in any Mac, it's going to be ridiculous. And if you shrink them to like 900 pixels by 700 or something like that, or anyways, you set the maximum width to 900 pixels, chances are it's going to be practically the same, except probably 4 meg smaller. So do that. Again, defer images below default. Create Spritesheets using tools. Don't make your designer do it because that's just lousy. But yeah, use Spritesheets anyway. Try inlining tiny dynamic images like Gravatars, well, gravatars are not a great example, but if you have something like that, consider inlining them because they can be, it can be more expensive to make the request than to inline them. Again, something HTTP2 fixes, but for the time being, it's still useful in some cases. And use CSS for simple icons. If you have to use like a circle, don't just add an icon for that. Just use CSS and be done with it. JavaScript. That's worded wrong. It should say you should be able to live without it. Because again, going back to the HTML section, you should have server-side rendering showing all the content that's relevant to the user. And in most cases, if you're not running a real-time video chat thing or something crazy like that, you probably don't need it that much. So again, defer all of it. You probably can get away with that. Use small modules, obviously. This is something that's becoming a norm nowadays, luckily. But yeah, if you're not using modules, use them. If you're using modules, use smaller ones. Use asset hashing, obviously, to cache JavaScript and CSS, and even images if you can, so that you can add the expires header and cache them away until they change and you use another hash. And cache vendor scripts separately because those tend to be the biggest parts of the site. So if you can get away with having a separate bundle for those, that one probably won't change as often as the user code. So it won't be downloaded as much, which is a good thing. So how do we do all of this, right? Well, questions? No, kid. Give me a second. There we go. So to do all of that, you can use Nginx. It'll solve everything. It's a reverse proxy. It basically, you can put it in front of your actual application. If you have Node.js, it's perfect for that use case. You can use it as a cluster or not, but anyways, it handles all of the static caching for you, shipping and whatnot. So all of the static content is taken care for you, and it doesn't add a load to the node process, which is huge too. It supports Speedy, and it has gzip by default. Set up a CDN if you want to or not. You can use Fastly, Cloudflare, Amazon CloudFront, and S3. Again, look into it. Maybe if you're like, okay, yeah, I really need a CDN, maybe try out Cloudflare first, which is cheap to free, and then maybe go with some other more enterprisey option. For shadow rendering, you can use Backbone and Render, but I don't think Render is actually all that well maintained anymore. You can use Angular, presumably in 2.0. I'm not even sure, but I've talked to a couple of guys from the Angular team, and they seem to be going to do it at some point somehow. You can also use Ember, even though their server-side rendering thing pretty much doesn't work, because all it does is it precompiles things for web crawlers. So yeah, not the point. Tonus, it's a thing I wrote. It has server-side rendering and client-side rendering. It also does some like progressive enhancement things. So if you're interested in that, check it out. Then there's React, which to me is the most reasonable option nowadays for this kind of thing if you care about performance and you want to serve full HTML pages from the server side first. Deferring assets, that's an easy one. For JavaScript, just use async. for styles or fonts, put them in a no-script tag, and then use JavaScript to create the same link thing, but set the media type to only X or something illegal like that, and then after a timeout, change it. And that'll, don't ask why, but that'll make it load asynchronously and not block. Unused CSS. This is mostly useful if you are using a huge framework like Bootstrap and only using like 3 different rules that they provide. And that's usually the case with Bootstrap, right? But you probably aren't using Bootstrap in production. So anyways, you have like the gold plugin, the grunt thing, and the command line tool. You do like uncss, pipe some website to it, and you'll get it. You'll get back all the CSS that's not unused. So you can just put that back in your style sheet. Probably you want to prettify it first, but it works. Critical CSS inlining is kind of hard because you have to load the page on Phantom.js or something like that and run this Penthouse script on top of that. And what Penthouse does is it figures out of all the CSS that you tell them to look in, which rules are affecting the content that's above default, and then it gives you that back in a chunk of standard output. And then you can use that to put it into style tag and defer all the rest. If you want something a little bit more higher level, you can use critical. That's an R module. It also comes with a grunt task, and I believe it has a gulp task. But what it does is it goes a step farther and actually does the inserting of the style tag for you. And it also, so you don't need to worry about that. And it also defers the rest of the CSS, which usually doesn't get modified, because that way, if you have different pages where each page has different styles that are critical to that page, then you can just serve the same style sheet for everyone, but serve different styles. So it gets cached, but the styles still change, so it's pretty good. So look into this one, I beg you. Use the font loader. Those are pretty simple to use too. You can do npm install font face and load. And basically what you do is you set your, instead of whatever custom web font you have, you use a website font like Helvetica or something, and then you run this script where when the callback is called, you just add another class name to the document and write over the font family. Optimizing images, again, really easy. Image min allows you to optimize all the images, but just when it comes to like bytecode, you can use graphics magic or stuff like that to automate the shrinking. And yeah, you should do that as soon as the user uploads the image or something. So these are both really easy to use. Image min comes, again, with the CLI, Gold plugin, Grunt plugin, and a programmatic API, so you can use it wherever you want. And it's really, really good. Creating Spritesheets, again, really easy. You can use Spritesheets for this. You basically tell it where your icons are, the individual icons, and it gives you back an image that's the Spritesheet, the CSS file, and it's actually well abstracted enough so that you can do whatever you want with the coordinates, and so it outputs stylus, less, Sass, JSON, wherever you want. So it's really simple to use, and you can integrate it into your builds. So that's great. Inline Images, just use the data URI module has a programmatic API, CLI, just do data URI, your image, you get back a data URI. So it's great. Mail system, you can use Babel or Browserify, or yeah, that's about it. Don't use anything else. And yeah, you're great now. So another thing you can use, Perf School, that's like a Node School workshop thing that runs in your command line. I wrote this thing so that you can go through the exercises, and it's pretty documented. So if you want to play around with everything I've been talking about, you can just run this and yeah, follow the exercise around. So in summary, measure your metrics, automate your metrics, define your budget, enforce it, prioritize your content, optimize your content, respect your humans, and respect our web. So I also wrote a book. It's called JavaScript Application Design. I have a couple here. So if you want one, I'll just give it to you. Just come talk to me. It talks about mostly all this stuff I've been talking about, but also it goes deeper into automation. It's divided in two parts. The first one is build automation and how to make your development processes faster and your deployment and testing processes faster. It talks about, in the second part, about modularity, asynchronous programming with JavaScript, testing, MVC, and whatnot. And then it also talks about REST APIs. If you don't want to buy anything from me, just come talk to me, and I give you one for free. Or also go to github.com/buildfirst/buildfirst, and there's 100 code samples that you can look at. So that's all I have. Thanks.